Question 9, one of your big wordy questions. We've got a mean of 28,500 and a standard deviation of 6,800. It's quite a wide standard deviation on that, isn't it? We're going to do a sample of 5, and we're suggesting it's going to be normal using a central limit theorem there. Unlikely to be a good model. So it's unlikely to be a good model because we're only taking 5. So n equals 5 is a very low number, given that this is almost certainly not going to be normal to begin with. Salaries in companies are not known to be normally distributed. There will be sort of 1 or 2 at the high end for the big managers, and then most of it in the middle and lower end. So it's unlikely to be symmetrical. So I think for A, I'm saying unlikely to be symmetrical, and n is very small, so not that great. But for part B, we're now doing 15 of them. And so the mean of 15, this we would use a central limit theorem here. It's still not a big number, is it? So the mean of the 15 of them is going to be normally distributed 28,500 and then 6,800 squared over 15 for that bit there. And we want the probability that the mean is less than 25,000. There's the first bit. And I mean, this is old style because the calculators can do this so well. This is not going to take a lot of work really, because it's just 2 different bits on the menu, isn't it? Where are we then? So normal distribution, we first of all want a less than 25,000 when the standard deviation is 6,800 squared divided by 15, and the mean is actually 28,500. And so that one there is giving us 0.0231. Yep, that's fine there. And I mean, what you were supposed to do in the old days here was just change this to 30,000. So you change that to 30,000 and that gives you 0.8035, and then take away what you just had. But we don't need to for ours because we've actually got a button here that does 25,000 to 30,000, and we can get the answer straight away there. So 0.7804. But it's nice to say how we'd have to do it before the calculator. You did less than 30,000, take away less than 25,000, similar to when we do integral bounds. Comment the accuracy. I mean, I still sort of comment on the accuracy of your estimate. I mean, it's still not great. I don't think. It's still not truly accurate. Since n is only 15, it's not a high number. It's still a small one, and that was unlikely to be symmetrical to start with. So I think it's still reasonably inaccurate.